Okay, so here in paging, the CPU will generate the page number and the offset. With this page number, it will look into the page table. It will look into the page table, and page table contains the valid bit, reference bit, and dirty bit. So valid bit is 0 means the page is not available in the main memory frames. So I already told you, in paging, no page is available in the main memory frames readily. So whenever it was requested, that will come and it will be loaded into the main memory frames. So initially, all the pages what valid bits are 0. Is it clear? So if any particular page is requested, that means you are going to demand a particular page. So whenever it was demanded or requested, then only it will come. It will load it. So P0, P1, and so on, Pn. So last class we already discussed. So if Px page is requested with offset D, then for example this is the Px. So this is the Px page, and frame is not it is not loaded into the main memory frames because all the frames are empty. All the frames are empty. So then what it will do? So it is requesting for Px, but it is not there in the main memory frames. So valid bit is 0. So what happens if this is the thing? Please respond. Px is requested, but it is not there in the main memory frames. That's the reason why the frame number is not introduced here. And also valid bit is 0. Valid bit 0 means, so here the frame numbers, no frame contains the Px 2. So what do you mean by that? So what happens? F3, F4, F5. For example, 6 frames are there. F0 to F5. 6 frames are there. All the 6 frames are not contained this Px. So what happens? So Px లేదు కాబట్టి valid bit is 0. So and the CPU is requesting for Px. What happens? Last class we discussed. It raises a trap. It raises a trap. Exactly. It raises a trap, and the trap will be given to the operating system. The trap will call it as. The trap is also called here. Yes, page fault, PF. Trap is also called page fault. So OS will understand why the page fault is occurred or trap is occurred. What is the type of trap? Page fault. So for which page the trap is raised? That is PX page. To whom this particular page is belongs to? Yes, this particular process. Okay, to whom this particular page belongs to? This particular process. Maybe process P1. Okay, then immediately the operating system will visit this P1 process which is there in the hard disk. Then it will get the PX PX page. For example, this is the PX page which is belongs to. This is the PX page which is which is there in the P1 process. Then immediately it will respond. It will get that one. And what happens? What's the next step? Make it the next step. I want to clarify. I want to move to the next step. So it was identified PX. It is there in the process. Then what is the duty of the operating system? Yeah, it has to load. Search for the page. Page found. Load page into load page into free frame. Okay, then load page into free frame. So then what it has to do? Search for free frame. So these are the steps that we have to consider. Okay, okay, so okay, so first one, CPU is identified the PX, look into page table. That's the first step. Page not frame number not found. Second step. Okay, then the frame number not found raises the trap. Third one. Okay, third step is raise a trap. Then once the trap is raised, it was catched by the operating system, and it will search for the requested page or demanded page. Search for page. Demanded page. Search for demanded page. That's the fourth step. Next, fifth step, page found. Demanded page is found. Then sixth step, load the page into the free frame. Load the page in free frame. Okay. So once if you want to load the page into the free frame, next seventh step, what it has to do? If you want to load into the free frame, you have to first search for the free frame. You have to search for the free frame. Okay. So now initially all the frames are free. So it will identify one of the frame. It will identify one of the frame. For example, F3. So it was taken F3. So PX is loaded into the F3. Then immediately next, what is this? Eighth step. Eighth step enti update page table. Update page table with frame number. Update page table with frame number. That is the eighth step. ఇప్పుడు ఏం చేయాలి? Instead of no frame number, I have to remove this. So what is the frame number now? What is the frame number now? F3. Then again raise a trap to send the information to CPU. Send info to CPU. Then నువ్వు ఏదైతే అడిగావో CPU, whatever the page number that you requested previously, its frame number is now ready. And here the page, valid bit is also set to 1. Valid bit, update the page table with frame number. So and valid bit is also set to 1. Then ఎప్పుడైతే valid bit 1 can set అయ్యిందో, then immediately send information to the CPU that yes, your requested page now is available in the frame number 3. Then same with the PX, again it will look into the page table. Then frame number will be generated. So now frame number F3 and offset will be transferred as it is. Then with the help of this offset, it will look into the main memory. Is it clear or not? So this will call it as page fault handling, the steps to handle the page fault. This is called steps to handle the page fault. Any doubt here? So if you have any doubt, you can ask. Is it clear or not? So I'll ask anyone. So please try to tell me the one by one step. Row number 10. Row number 10. What is the first step? Please respond fast. Roll number 10. What is the first step? Please switch on your voice and respond fast. Please don't waste the time. What is the first step? నేను చాలా క్లియర్ గా ఇక్కడ ఉంది. చాట్ లో చెప్పండి పోనీ. ఇప్పుడు పని చేయదు మీకు. అవసరమైనప్పుడు పని చేయవు. Tell me what is the first step? The first step is the CPU will look for the page number and for the frame number and its corresponding frame number not found. Second step is frame number not found. Next, third step is because the frame number is not found, it will raise as a trap called page fault. Then fourth step is, so why it is happened, the page fault is happened because the required page is not available in the main memory frame. Required page is not available in the main memory frame, any one of the main memory frame. So the page is there or not, it will search. That's the fourth step. Yes, page is available. Page found, fifth. Next, once the page is found, then the operating system's duty is to load the page into the main memory, free frame of the main memory. That is the sixth step. Then if you want to load the page into demanded page into free frame, first you have to search for the free frame. Yes, free frame is available because all the frames are free frames. So now when one of the frame is requested, one of the frame is loaded with the page demanded page PX, then that information should be updated in the main memory frames, page table, that should be placed in the page table. So immediately in 8th step, update the page table with the frame number and valid bit will be set. Is it clear? Then what is the 9th step? So 9th step is immediately once the page table is updated, immediately that information is sent to the CPU. Then again the CPU will request for the same page. Then now it will returns the frame number. So now it will returns the frame number and the logical address is converted into physical address. Is clear? So this is how the page fault will be raised. So now, so my intention is to please try to understand the concept. My intention is to fulfill the page tables, fulfill the page faults. My intention here, that means operating system intention is to fulfill the page faults. What do you mean by page fault? What do you mean by page fault? Anyone? What do you mean by page fault? Number 78. What do you mean by page fault? Roll number 78. Please on your voice, audio, and tell me. Please make it fast. Number 78. What do you mean by page fault? Roll number 78. What do you mean by page fault? if the requested page is not available in the main memory frame, then operating system will raise a trap. The trap, I will call it as page fault. I'll repeat again. Whenever a page is requested by the CPU, that requested page is not available in the main memory frames, then operating system will raise a trap called page fault. That is called page fault. Please, number 78. So you don't want to respond? Number 78. So number 78.
Sir.
So can you please repeat that statement? Page fault. What do you mean by page fault? Please make it fast. Don't waste my time. You want to respond or you don't want to respond? Number 78.
Sir.
Tell me what is page fault. You know, already మీకు చెప్పాను కదా ఇప్పుడే. Tell me. Okay.
Place the type of exception.
It's a
Exception.
type of exception.
Yes, sir.
Exception అంటే ఎక్కడ వచ్చిందమ్మా? So you are not listening, I think. It's a type of trap. It is not an exception. చెప్పండి ఏంటది? Okay, it's a type of exception. Okay, then it's a type of exception. Then so why that exception is occurred? LE14 is there. LE LE17
Sir.
What is page fault? What do you mean by page fault? Whenever a CPU is requested for a page and it is not available in the main memory frames, then the operating system will raise a trap, and that trap I'll call it as page fault. So nobody is listening. Yes, yeah, that is your choice. I don't want to. Okay. So now. Okay, so like this, the number of page faults occurs. For example, I want to take the same example. So now px గురించి ఒక page fault occur అయింది. Okay, so page ని load చేశాను. Next py గురించి అడిగింది. So py ని ఇక్కడ పెట్టేశాను. pz ని ఇక్కడ పెట్టేశాను. PA, PB, PC. Okay, so PA, PB, PC. Okay, now all the frames are full. Now all the frames are full. Okay, because 0, 1, మొత్తం total గా 6 page faults occurred. So now 6 page faults are occurred because initially all the frames are free in the main memory frames. So I requested for number of pages. First px అనుకున్నాం కదా, px, py, pz, then PA, PB, PC. No problem. All the pages are belongs to this particular process. Okay, so because all the frames are available, that's the reason why I loaded all the pages. Page faults are raised, and page fault has loaded all the requested pages in the main memory frame. Then PD is required now. So my problem here is PD is required. What happens? Again, is PD, for example, is PD. Is PD is available in the main memory frame? Is PD is available in the main memory frame? Please respond. Is PD is available in the main memory frame? Yes or no? Is PD is available in the main memory frame? There is a new page that was requested by the CPU. Okay, so now instead of PX, is requesting PD. Is PD is there in the main memory frames? Is PD is available in the main memory frames? No. PZ, PY, PX, PA, PB, PC are available. But PD is not available. What happens? Again page fault. Okay. Page fault raise cheste em avutundi. Operating system will take the page fault. Then it will search. Yes, PD is there. Okay. PD is the page that was available in the process. Now found, PD is found. Then I want to load the PD. Then search for the free frame. Search for the free frame. Is free frame is available? I want to load PD. But no free frame is available. Is free frame is available? Is free frame is available? No. So the page fault is trying to identify, please try to understand, the page fault mechanism is trying to identify among these frames, any one of the frame will be the victim frame. Victim frame. Among the page frames, one of the victim frame. And how I will make it as a frame as victim frame? By selecting one of the page as a victim page. Victim page. Okay. So by selecting one of the page as a victim page, and I will try to make out that particular page. I'll try to remove that page from the frame. What happens? If I remove that page from the frame, what happens? What happens? You will get free frame. Okay. Then instead of PX, I'll try to load PD. Okay, I made PX as a victim page, and that's the reason why this frame is called victim frame. So it was free now. Then which page is waiting? PD is waiting. Then the waiting page will be loaded in the free frame, and PX will be kept out. PX will be kept out. So this is called victim page. This particular page is called victim page, and PD is the demanded page. PX is the victim page, PD is the demanded page. That demanded page will be loaded into the newly formed free frame or victim frame. Victim frame. This particular procedure, I'll call it as page replacement algorithm. This is very important. Is it clear? I'll repeat again. What do you mean by page replacement algorithm? The page replacement algorithm will be implemented in page replacement algorithm will be implemented in page fault. Avuna kada? Page replacement algorithm will be implemented in the page fault. When the page replacement algorithm is implemented, when the page replacement algorithm is implemented, when the page replacement algorithm is implemented in the page fault, if when the page replacement algorithm is implemented in the when the page replacement algorithm is implemented in the page fault, if free frame is not available. Okay, the page replacement algorithm is an algorithm which will identify the victim page among the pages that are available in the main memory frames. I'll repeat again. Page replacement algorithm is an algorithm which will identify the one of the page as victim page among the pages that are available in the main memory frames to create the victim frame or free frame, to create the free frame, to load the demanded page, to load the demanded page. Are you getting the point or not? Okay, so that is the purpose of free page replacement algorithm. Okay, so now I'll try to discuss different page replacement algorithms. So if you are clear about this, I'll go for the page replacement algorithms. Why the page replacement algorithm is required? Okay, so now okay, so why the page replacement algorithm is required? If the pages, if the page is not a requested page is not available, it will raise a page fault. And if the page fault mechanism is trying to place that particular demanded page into the main memory frames, the free frame is not available. Then only the page replacement algorithm will be triggered. Is it clear or not? If the free frame is available, then no problem. In that free frame, demanded page will be loaded. If the free frame is not available in the main memory frames, then only page replacement algorithm will be triggered. Is it clear or not? So now, so what are the different page replacement algorithms? What are the different page replacement algorithms? Okay, now basically there are three page replacement algorithms. Basically, there are three page replacement algorithms. One is optimal page replacement algorithm. Second one is first in, first out page replacement algorithm, and least recently used page replacement algorithms. So these are the basic page replacement algorithms. Okay, optimal page replacement algorithm, first in first out page replacement algorithm, and least recently used page replacement algorithm. So what is the input to the page replacement algorithm? The main input to the page replacement algorithm is number of page requests. Okay, number of page requests. Next, this is the first input. Then number of frames that are available, number of frames that are available. Then so these are the three main inputs. Then output is number of page faults. Number of page faults. Any particular page replacement algorithm, the duty is so minimize number of page fault. For the given situation, the page replacement algorithm has to take the page requests like P0, P1, P2. Maybe again it may ask for P1, maybe it may ask for P0, P5, P3, like this. So these are the different pages that are requested by any process. Is it clear? So all these pages in the process has to use maybe 3 frames, 4 frames, or 10 frames. Okay, it has to utilize the available frames. It has to utilize the available frames. By utilizing the available frames, it has to make available to execute. The pages has to be available in the main memory frames to execute. Okay, in the process of make available the pages in the main memory frames, the page replacement algorithm has to look for the page faults. So it may make available, but the number of page faults goes on increasing. The page replacement algorithm is not a optimum page, is not a good algorithm for that situation. So you have to check, or you have to choose a right page replacement algorithm. You have to choose a right page replacement algorithm to. You have to choose a right page replacement algorithm to search for the victim page and make the free frame and load the page, demanded page. Okay, so that is all about page replacement algorithms. The algorithm is implemented like this. The input is reference string, number of frames. Reference string means the sequence of page requests. I will tell you what do you mean by reference string. Then output is number of page faults. Finally, output should be number of page faults, and it should be as minimum as possible. Is it clear? So then find the location of the desired page on the disk. I already told you, because I am requesting for a particular page that is available in the hard disk. So first I have to get that page. Then find the victim page. Is it clear? So scan the pages present in the main memory frames. Adega cheppanu. So main memory frames lo unna pages ni mundu scan chestanu. Aa scan chesina vaatilo I'll follow the criteria. I'll tell you the criteria, what criteria I want to follow. Based on that criteria, I have to select the victim page. I have to select the victim page. Then swap out the victim page. So if I swap out the victim page, I will get the free frame. If I swap out the victim page, I will get the free frame. Then in that particular victim page, I will load the demanded page. Okay, swap in the demanded page into the free frame. Then update the page table by setting the valid bit equal to maybe either 0. that 0 or 1. If I load the page victim page, if I load the page into the main memory frames, if I load the page into the main memory frames, definitely what I have to do, valid bit should be set it to 1. Yes, exactly. Then what I have to do, so I have to send a signal to the CPU that yes, whatever the page that was requested, that is ready now. Is clear? So that is the duty of the page replacement algorithm. Is it clear or not? Is it clear or not? Okay, so now I'll start. A reference string. I already told you. I did. So a reference string, it represents sequence of page requests. Reference string means sequence of page requests. For example, I'll try to R, reference string R, 1, 2, 5, 4, 6, again 2 or 1, again 5, 2, 3, 6, like this. So this is called reference string. Reference string is equal to 1, 2, 5, 6, 8. It means that the user is requested, the CPU is requested for page P1. After that, he is requesting for P2, then P5, P4, then P6. Again, you can ask P2. Again, you can ask P1. Again, you can ask P5. Okay, so it may repeat. P2 again, you can ask P3, P6. So this I'll call it as a valid reference string. This I'll call it as valid reference string. Reference string. So you want to explain the algorithm again? Okay, definitely. Okay, so here in the page replacement algorithm, okay, in the process of that, you may get the clarity. So Sandhya, you please try to listen, you will get the clarity. Okay, so a reference string, first input is reference string. For your algorithm, first input is reference string. So reference string should be, please try to listen carefully, because the same concepts you have to practice in your lab also. Okay, you have to define your own reference string and you have to write your own C program to simulate this particular algorithm. Is it clear? So that's the reason why you please try to understand this concept. So reference string means sequence of page requests. Is called sequence of page requests. So 1, 2, 5, 4, 6, 2, 1, 5, 2, 3, 6. Randomly I chosen these requests. So this is a perfect and exactly requested sequence of page requests. For example, I am going to 1, 2, 2, 2, 1, 5, 5, 4, 6, 6, 6, 3, 2, 1. So if the reference string is like this is invalid string. Why? Because you just remember, you will never represent like this. You should not represent like this. So the valid reference string for this particular reference string is 1. So for the 3 2s, I have to mention only 1 2. Then again 1. For 2 5s, I have to mention 5. 4. For 3 6s, I have to mention 6. 3, 2, 1. So this is correct. Is it clear? So you should not repeat side by side the same page. It means that your CPU is requesting for the same page. Then no need to represent immediately side by side. So you are requesting for the same page, no need to represent side by side. So one, CPU is requesting for one, is requesting for two, again it is requesting for two, means yes, the two is already there. Okay, so then 1, 5, 4, 6, 3, 2, 1. Is it clear? So this is the valid string that like this you have to represent. This is the wrong representation. You should not represent like this. You should not represent like this. So this is the wrong representation. So now the page requests are available. Page requests are available. And then next input is frames. Second input is frames. Number of frames that are available for this particular algorithm. So maybe 4 frames, maybe 5 frames, so maybe 3 frames. So these are the requests, page requests, and you have to utilize 0, 1, 2, 3 frames, or 0, 1, 2, 3, 4 frames, or 0, 1, 2 frames. Using these frames, you may use this 4 frames case, or 5 frames case, or 3 frames case. Is it clear? So either you have to use 4 or 5 or 3. You have to fulfill these requests. Fulfill these requests. So this is called number of frames. Number of frames available. Is it clear? So now his input is clear. Reference string. What do you mean by reference string is clear? Input. His reference string is clear? Yes. Next, number of frames is clear now. Okay. Then now what output it has to get? So finally, number of page faults. What do you mean by page fault? We already know. For example, I'm taking the same. I'm taking one particular reference string. Just looking, 1, 2, 3, 1, 2, 1, 3. Maybe this is 4. So maybe this is 4. So please consider. So this is 4. Okay. I have 3 frames. This is the input. So number of frames equal to 3. Emma. Input reference string is 1, 2, 3, 1, 4, 1, 3. And my number of frames are 3. 0, 1, 2. Then what is your page replacement algorithm? What is page fault? What is page fault? Initially, CPU is requesting 1. Please try to listen carefully. Reference string. CPU is requesting first page 1. Is page 1 is available in the main memory frames? These are main memory frames. Is page P1 is available in the main memory frames? Yes, Sanja. Is page is available in the main memory frames? 1 is available in the main memory frame? లేదు కదమ్మా, ఇది frame number ఇది. So better I'll try to mention F0, F1, F2. Okay, so P1, P2, P3, again P1, P4, P1, P3. So ఇప్పుడు మీకు confusion ఉంటుంది. Okay. Okay, so 1 is available in the main memory frames? Yes or no? Is P1 is available in the main memory frames? No. Then what happens? What happens? If the requested page is not available in the main memory frames, what happens? Tries a trap. What is that trap? Page fault. So PF equal to 1. Then what the page fault will do? Page fault mechanism will do? What the page fault mechanism will do? It will get the page number P1 from the hard disk, and that will be loaded into the main memory frame because all the frames are free. So P1 will be placed here. So instead of P1, I am just placing 1 in F0. Is it clear or not? Page fault is raised. So PF equal to 1. Now, next I will go for the P2. Is P2 is available in the frames? Is P2 is available in the frames? Again what happens? Again what happens? Page fault will raise. Already 1. Now 2. Second page fault. Then 1 is already there in the frame. Then 2 ఏమవుతుంది? ఇప్పుడు free frames ఏమేమి ఉన్నాయి? What are the free frames now? What are the free frames? F1, F2. Is page replacement algorithm is required now? Is page replacement algorithm is required? No, because free frames are available. ఇప్పటి వరకు free page replacement algorithm అవసరం లేదు because already free frames are available. So 2 will sit here. Then completed. Then request for P3. Is P3 is available in the frame? No. Then what happens? 1 and 2 is there. So page fault will rise again because P3 is not there. So third page fault. Then page 3 will enter. Next, P3 is completed. Okay. Then I am requesting for P4. Sorry, P1. I am requesting for P1. What happens? Please anybody tell me what happens? Is page fault will rise? Is page fault is raised? No. No. Page replacement algorithm introduce ఎందుకు అవసరం? సంధ్య page replacement algorithm అవసరం లేదు కదా? చూడండి, I am requesting for P1. Is page fault will rise? No man, I am requesting for page P1 because P1 is already there. No page fault will rise. It will use the same page number. No, page P1 is already available in the free frame, already available in the frame. So the P1 is requested, and if it is available already in the main memory frames, it will use. Is it correct or not? Is it clear or not?
Yes, sir.
Now, ఇప్పుడు P4 చూద్దాం. ఇప్పుడు మీరు అన్నది కరెక్ట్. ఇప్పుడు P4 చూద్దాం. ఇప్పుడు P4 లోపల ఉందా? ఫ్రీ ఫ్రేమ్స్ లో ఉందా? సారీ, ఫ్రేమ్స్ లో ఉందా? Is P4 is available in the frames? No. అప్పుడు ఏమవుతుంది? పేజ్ ఫాల్ట్ రైజ్ అవుతుందా? Is page fault rise or not? Yes. So ఇప్పుడు P3 వల్ల ఇంతకు ముందు చూడండి, P1 అడగటం వల్ల P1 లోపలే ఉంది కాబట్టి page fault is not raised. Same PF ఇక్కడ PF equal to 3 ఉంది, ఇక్కడ కూడా PF equal to 3 ఉంది. It means that it is already there in the free frames. In the frames, then it is using. Is it clear or not? So ఇప్పుడు ఇక్కడ ఏంటి? దీంట్లో 1 2 3 F0 F1 F2. ఓకే, F0 F1 F2 3 ఫ్రేమ్స్ ఫిల్ అయిపోయింది. అండ్ నేను ఏం అడుగుతున్నాను, P4 అడుగుతున్నాను. ఈ 3 frames లో ఉన్న pages లో ఏ పేజ్ అయినా P4 కాదు. సో అప్పుడు ఏమవుతుంది, ఇట్ ఈస్ రిక్వెస్టింగ్ ఫర్ P4. సో page fault is raised because P4 is not available. It is requesting for P4. Then P4 ఎక్కడికి రావాలి, 1 ని తీసేయాలా, 2 ని తీసేయాలా, 3 ని తీసేయాలా? Which one I have to remove? Which one I have to remove? So what is required here? What is required here? Page replacement algorithm. Is true or not? Is it clear? Okay, ఇప్పుడు నాకు అవసరం అన్నమాట ఈ పర్టికులర్ సిచ్యువేషన్ లో. సో వాట్ ఐ హ్యావ్ టు డూ ఇస్, ఈ 1 ని తీసేయాలా, 2 ని తీసేయాలా, 3 ని తీసేయాలా? సో ఐ హ్యావ్ మై ఓన్ క్రైటీరియా. Based on the criteria, the page replacement algorithms are classified into 3 categories. Optimal page replacement algorithm, first in first out page replacement algorithm, and least recently used page replacement algorithm. And in chala unnai most recently used page replacement algorithm, number of page replacement algorithms are there. So I'll try to discuss basic page replacement algorithms. Then if time permits, I'll try to cover the remaining algorithms also. So next class, I'll try to continue the same algorithm, same example, with the help of different page replacement algorithms. Hope the concept is clear, I think. Is it clear? Okay, thank you. Thank you very much. So we'll discuss in the next class.